Hi folks, my name is Ms. Midha, and today we're going to focus on the following question. How can we use what we know about normal distributions to determine whether the results of an experiment are significant? So we're going to be actually looking at two different experiments today, two different situations, and we're going to be given a whole set of data for each of those situations. We are going to have to figure out if we have enough information, enough evidence to answer the given questions. So let's get started. All right, so one more time, these are the instructions. You're going to read the situation that's going to pop up over here in a moment, as well as the given data, and then determine whether you have enough information to answer the question. If you do, answer the question. All right, so here is the situation. Some students claim that listening to their favorite song before a test improves their score. 12 students offer to test the hypothesis by first dividing into two groups at random. One group will listen to their favorite song before taking a standardized test, and the other group will take the standardized test without listening to the music before the test. The scores from the standardized test are collected and analyzed. Does listening to music affect the outcomes for the standardized test? Okay, now this is our data. The mean score for the group that listened to their favorite song is 1,082.16. The mean score for the group that did not listen to music is 996.33. The difference in mean scores for the two original groupings is 85.83. 100 trials are run in which the data are randomly assigned to two groups. 27 trials have a difference in means of at least 85.83. And 38 trials have a difference in means of less than negative 85.83. So again, I'm going to ask you first to pause your video and take as long as you need, right? Reread the situation if you need and go through each of those pieces of data. See if you have enough information to answer the question. Again, the question is, does listening to music affect the outcomes for the standardized test? If you don't have enough information, think about why that is. And if you do have enough information, you can go ahead and answer the question. Once you think you have everything done, unpause the video and we will review. All right, so let's think this through. Now, one thing that you might want to sort of think about that might be helpful in order to determine whether you have enough information is thinking about what the difference in means are from the original grouping, right? Because this gives you a benchmark against which you could measure the information about the trials in which the data was randomly regrouped, okay? And sort of keep this in the back of your mind for the situation that we're looking at right now and the next situation, the next experiment that we'll show in a few moments. All right, now in terms of this situation, does listening to music affect the outcomes for the standardized test? Now, given all this data, there's still actually not enough evidence. There is not enough evidence to say that the difference in means is due to anything other than the way the students were grouped. So we don't have enough information to actually answer this question, right? There's not enough evidence. Now, how do I know that? Well, if I look at this information down below, I notice, first of all, the difference in mean scores for the two original groupings was 85.83, right? And I notice here, out of the 100 trials, 27 trials had a difference in means of at least 85.83, and 38 trials had a difference in means of less than negative 85.83. So what is that telling me? Well, that's telling me that 65 of the 100 trials from randomized groupings, 65 of the 100 trials had differences in means more extreme than the difference in the original groupings. Therefore, the difference from the original groupings does not seem significant enough to claim that listening to their favorite song made a difference in the score on the standardized test. So in this situation, unfortunately, we do not have enough evidence, we do not have enough information to answer this question. All right, let's look at the next one then. So here is our new situation. Medical professionals are studying a new type of antidepressant that is meant to reduce the length of time needed to feel the effects. 20 people suffering from diagnosed depression are split into two groups at random. One group is given the current popular medication and the second group given the new antidepressant. Participants in the study are asked to report how long it takes until they notice a lasting change in their mood. The professionals want to know which antidepressant is better to prescribe to patients. Is one medication better than the other? Now, here is the data. The mean for the popular antidepressant is 8.9 weeks. The mean for the new antidepressant is 4.6 weeks. The difference in mean times for the original groupings is 4.3 weeks. 100 trials are run in which the data are randomly assigned to two groups. The difference in means for the randomized groupings is approximately normally distributed. The mean difference in means for the two randomized groupings is 0.05 weeks. And finally, the standard deviation of the difference in means for the two randomized groups is 1.4 weeks. So again, pause the video for as long as you need. Reread the situation as many times as you need to, along with that data that we're given, and see if you can figure out if we have enough information to answer this question, right? Is one medication better than the other? If you have enough evidence, answer the question. And if you don't, think about why that is. Once you're done, unpause again, and we will review. All right, so good news for this one. We do have enough evidence. We definitely have enough evidence to determine that one antidepressant is better than the other. Now, how do we know that? Well, using a normal distribution with a mean of 0.05 and a standard deviation of 1.14 weeks, only 0.02% of results would have differences that are more extreme than the 4.3-week difference in means from this original groupings. I'll say that again. Using a normal distribution with a mean of 0.05 weeks, right? We're given that information, and a standard deviation of 1.14. Only 0.02% of results, only 0.02% of results would have differences that are more extreme than the 4.3-week difference in means from the original groupings. Now, what does that mean? Well, really what that's telling us is that the differences in means is very unlikely to have resulted. Very, very unlikely to have resulted only from the way in which the groups were selected. So that's telling us the difference in means is most likely due to the medication. Again, what helps here? What really helps more than anything else is really thinking about, the first thing to think about is the difference in means from the original groupings, right? And then once you have that and you notice, oh, okay, this information is approximately normally distributed. I have my mean difference is the mean difference in means for those two randomized groups is only 0.05, right? And using that information about standard deviation as well, it allows me to determine that we do in fact have enough evidence here. Okay, so what were we able to do today? We basically looked at these two different situations, these two experiments, and we assessed whether the results from an experiment were significant, right? Or just due to chance groupings. So really what we were looking to do was determine if there was a significant difference in means or whether the difference is due to random grouping.